So these projects simulate a smart home environment using a Cisco packet tracer IoT to demonstrate how everyday devices can be automated and interconnected using networking and IoT principles. Each room, which is zoned in this house, such as the living room, bedroom, garage, front porch, and backyard, contains IoT devices and sensors connected through a home gateway and wireless access point to a central IoT server for monitoring and automation. We have devices in each zone which plays different role. For example, router with configuration 192.168.0.1, which is a default gateway for providing internet access to the smart home. Switches connected wired devices in different rooms to the gateway. Wireless access point WAP provides Wi-Fi for IoT devices like smart bulbs, phones, and sensors. Home gateways handle up connecting all IoT devices and linking them to the IoT server. IoT servers, which registers with IP 192.168.0.2 and manages all IoT devices and handles automatic logic and user access. Each IoT device connects to the home gateway using Wi-Fi. The IoT server automatically detects and registers the devices. Registered devices appear under the gateway, which is also known as IoT device list panel. Each zone functions autonomously under the central gateway. The IoT server handles logic, automation, and user control. DHCP and DNS plays an important and a very senseless role in these connectivity. These ensures a seamless connectivity between the devices. Users can remotely monitor and control all systems via smartphone or web interface. Where we'll explain every zone in this. For example, the red zone, which contains components like smart door, door sensor, motion detector, and smart light with smart camera and smartphone. The door is connected to the home gateway via wireless IoT network configured to open when motion is detected. The door sensor registered with IoT server sends trigger to gateway to activate camera or light. The motion detector is linked with the automation rule. If motion detected, turn on porch light plus activate the camera. Smart light is configured as an IoT device controlled automatically via gateway or manually from smartphone. Or we can also use this including connected via Wi-Fi. A smart camera is IP-based device connected via Wi-Fi, triggered automatically for surveillance. Smartphone used by user to unlock door or view camera feed remotely, connects to IoT server via Wi-Fi or through remote access. Then we'll move to the green zone. Its purpose is simply provides comfort and smart energy management through automatic lighting and cooling. The components include smart light, fan, temperature sensor, motion detector, and smart plug. Smart light automatically turns on when someone enters, controlled via motion detector through a home way gateway automation. Smart fan activates when room temperature increases or motion is detected. Linked to temperature sensors and motion detector automation rules. Temperature sensor sends data to gateway triggers fan or AC based on temperature threshold. Monitors temperature in the living room and motion detector detects human presence in the room. Primary trigger for fan and light automation. Smart plug used for additional appliances, example laptop, TV, or lamp. It is controlled manually via IoT applications. IoT gateway, which is a wireless home gateway, central device controlling all smart devices, connected to router and IoT server, DHCP enabled with all the IoT devices registered here. We should know that DHCP provides regular IP addresses automatically to the devices which are present there. If motion detected, light plus fan will be on. If no motion for 2 minutes, light plus fan will be off. These are the examples of these automations. Then we'll move to the purple zone, which consists of important components like smart light, smart fan, air conditioner, window sensor, and motion detector. Here, window sensor is a component which haven't we haven't discussed. The window sensor detects if window is open. Automatic rule if window open, turn off AC. Configuration summary is linked with via Wi-Fi to a gateway, configured to switch on or off automatically. Then we'll move to the blue zone. It handles vehicle access and garage lighting automatically using sensors and smart control. If motion detected, open garage plus turn on garage light. The IoT switch plays an important role here, which provides wired connection for garage network. connects all garage devices to a gateway and router. Then we'll move to the backyard sections, implements outdoor automation and environmental monitoring using IoT. Smart sprinkler system activates when high temperature detected. It is controlled by IoT route based on temperature sensor reading. Smartphone and tablet allows remote monitoring or manual control. We can connect it through the Wi-Fi or to the IoT server. The IoT switch connects backyard devices to home network and ensures seamless communication with the gateway. The central network components include router, home gateway, IoT server, switches, and access point. Router purpose is provides internet connectivity and acts as a default gateway. For example, in this case, we used IP with 192.168.0.1, and this is automatically assigned through DHCP with domain name system enabled. Home gateway is central IoT controller for all devices. IoT server manages device registration, automation, and monitoring through DHCP and DNS. The static IP which we have used here is 192.168.0.2, which is a host for IoT services. Switches per zone, where there are local switches in every zone, which connects multiple wired IoT devices. Each zone switch connects to router or gateway. Access points are those where which provides wireless access for IoT devices in large areas. SSID is smart home Wi-Fi linked to a gateway, which is used here. Communication and automation workflow. Sensors detect environmental changes, for example, motion, temperature, or door setup. Triggers are sent wirelessly to a home gateway. The gateway consults automation rules stored on the IoT server. Appropriate actions are executed, example, turning lights on or opening doors. User devices are smartphones and laptops can monitor or override actions remotely. If a temperature raises from 28 degrees Celsius, for an example, the air condition will be turned on. The window sensors will be turned off with window open. Summary includes each zone functions autonomously under the central gateway. Devices communicate through IoT protocols, which is MQTT or HTTP. DHC and DNS ensure seamless connectivity. Users can remotely monitor and control all systems via smartphone or web interface. Component icons, images, and and configuration fields are applied here with with the help of DHCP and DNS.
As my fellow mate has explained all the components, now I would like to show how one can access the smart devices by showing you the live example. So basically here we are going to switch on the fan. I'll show you how. So here the packets are being transferring from the smartphone to the fan of the living room. So here it has been showed that the fan is turned on.